as the two waves I'm taking. So this is your y1 omega t, and the other one is your y2, and this is your omega t x-axis. The two waves are there, which we are trying to understand destructive interference. So say first one is starting from origin, it will go to the maximum, go down maximum, go up maximum, go down maximum, and so on, right? And the second one, suppose if it is starting exactly at this point, what will happen? Check yourself, you will understand within no time how the dark fringe is being obtained, right? So these are the points I have taken right up to the down, because we are going to discuss how the dark fringe is formed. So for that, I am taking these points also, the peak point also. Take them down to understand clear picture about the dark fringe. Right. Now here, as I told you, that I am taking by the next figure, which is starting, I'm in the y2 is starting after lambda by 2, right? After lambda by 2 means half wave. After lambda by 2 means half wave, right? So make it having the same frequency, everything same, source was same, coherent, frequency was same, amplitude was same. Here we have kept it. So please draw this accordingly. Same amplitude on this side, then it will come on this side, then it will go like this, and so on, right? See what happens. Here we are seeing that we are getting the trough of y1 coinciding with the crest of the y2, the golden one, correct? Trough of the y1 is coinciding with the crest of the y2. What will happen? They are having the same magnitude, but one side amplitude is same, right? But one side is negative, other side is positive. If this fellow is minus a naught, the other one, which at this point where they are interfering, this is your a naught. If I am adding them, it is 0, correct? So I'm getting my y is equal to y1 plus y2. And check it, here we got it 0. So once I'm trying to draw the resultant, okay, just below that I'm going to draw the resultant. Let's see what happens to y. So, okay, once they are at 0, 0, where is that? Both are 0. If I'm adding, they are 0. If you come to the maximum, again, we are getting 0. So here 0, at this point also 0. Any point in between, you can check it. Whatever negative side value is there in y1, same positive side value will be there for y2. So if you add them, again 0 only in between also. Similarly, you go further, here both of them after half cycle of the y2, you see both are crossing the x-axis. One is going up, other one is going down. So yes, that point is 0, 0, so 0. Next, you see here it is trough, and here it is crest. So if I come down, I'll get 0. Next one is 0 and crest and trough again. So 0, 0, 0. I'm getting a perfect dark fringe here, right? So no amplitude. No amplitude means no intensity, because as I told you, intensity is your directly proportional to the amplitude square, right? Yeah, I'll write here the intensity of light directly proportional to the amplitude whole square. Always remember this, many points we are going to have. Intensity is energy is directly proportional to the intensity. So we can write energy at that particular point. It will be amplitude square. Any time amplitude is continuously varying. So I'm talking about the resultant. We are talking about the resultant intensity, the light of the resultant. So amplitude also of the resultant, right? So here we are getting it zeros all the time. So intensity of light will be 0, yes or no, right? So here we can write for resultant. This is for resultant. We'll have this intensity of light is directly proportional to the amplitude square. So if you apply for this case, you are going to have amplitude square means resultant amplitude is 0, so 0, all the time 0, right? So y I'm going to have all the time, I'm going to have y is equal to 0. This forms a perfect dark fringe. We'll call this as df. Okay, and where it is happening, when it is happening, first time we had seen if the phase difference between them is how much? This is half cycle, half circle. So it is your pi, correct? Half circle means it is your pi. So yes, it will happen, the dark fringe will happen if your phi is how much? This is just pi, and the next one is how much? It cannot be 2 pi. 2 pi, it will become a constructive as we have seen earlier. So it will be now 3 pi. The things will repeat itself. How come? Check yourself. Suppose in place of
After
here,
pi,
it
sir?
is, yeah, after pi, it cannot be 2 pi. If this y2 is starting at 2 pi, then though it will be just a constructive interference. This fellow is going up. This fellow also will go up. So it will become a constructive. We want a destructive interference. For that, y2, where it has to start? It has to start where? Tell me. It has to start upward only. So where it has to start? It is going to start at this point where the white one is going down. So you can just suppose the one cycle of y2 erase, you will be finding again the condition where I'll be finding my destructive interference. So here 0 for the white one, origin is the 0, origin is the thing. Now for the case under consideration, we had seen that if my phase difference is pi, then it is going to happen the destructive interference. Next will be how much? 1 pi, 2 pi, 3 pi. So it will happen at 3 pi where this golden one is going up, y2 is going up, while white one is going down, y1 is going down. If you add them, same story is going to write. Yes or no? Is it clear? So next, when it will be? After that, it will be a 3 pi. Similarly, 5 pi, 7 pi, and so on. In terms of now, the path difference, how much it should be, where it should be. Yes. In terms of the path length difference, once they arrive, pi is equivalent to, yes, how much? This is half the wavelength.
Pi by
So
2.
lambda by 2, I mean, this
Okay,
is
lambda,
path
sorry,
length
lambda.
difference. Yeah, because wavelength is the length.
Yes,
So
sir.
x is the path length difference, and that lambda by 2. Next one will be how much? 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, and so on. Can we write like
Well,
this?
sir, so for constructive interference, will it be like pi to 2 pi, 4 pi, 6 pi? It will
No,
be like
pi
that.
will not be there. 0,
Okay.
2 pi. Yeah,
Hmm.
0, 2 pi. In between, you are going to have, if the path length difference
Hmm.
is, or phase difference is like this, you are going to have constructive also. What you said, if it is like that, that is what we had seen earlier in the above
Yes, sir.
case.
Yes, sir.
Yeah, when it is happening, minded this x is known as path length difference, right? X is your path length difference. Now check it, come back to our figure, and we'll see lambda by 2. If the path length difference is lambda by 2, or equivalently we can say phase angle difference is pi, how the things are taking place on the screen. So let's come back to the same figure. I mean, the wave which is arriving at 1 here, on either side, you will find that crest of one is coinciding with the trough of other, right? These are the points where crest of your y1 say is coinciding with the trough of the y2. You can check the point 1, this line. So the ray which is arriving here, right, at with these 2 points at 1, say I'm taking this one, slightly tilted, so I'll redo it. Change the color also for you. So fine. I'm taking the next one from A, arriving at 1, correct? And then from B, arriving at 1. There is a path length difference, correct? See the distance, the lower one is traveling more than the upper one. Am I right? So what will happen? There will be a path length difference. What is that? X. So path length difference X has to be given in terms of the wavelength. Whether it is 1 wavelength, 2 wavelength, or half wavelength, or 3 half wavelength, or 5 half wavelength, like this. Is it clear? Are you getting it what I said? So 1 is such point on either side, right? Lower one, if you take it, from A, it will have the longer path than the lower one from B. But the path length difference, X, will be such that it will be either lambda by 2 or 3 lambda by 2 or 5 lambda by 2 and so on. So on either side of the central bright fringe, we are getting alternate dark and bright fringe. First bright fringe after the central bright fringe, if you take it, what should be your lambda? I mean the X here, the path length difference, how much it should be? First bright fringe. Here in our figure, this is 2 and 2 on either side. How much it should be? Can you make it out in terms of the lambda? Whatever we have discussed based on that. First one is 0. Again, I remind you. First one is 0. Check it. We had here for bright fringe. Your 5 was equal to 0. So your X will be equal to 0. X is, again, I remind you, this is your path length difference arriving on the screen. How much path length difference? X. So 5 is 0. This is also 0. That is your central bright fringe. We had seen that there is no path length difference for the rays which is arriving at O, center of the screen. No path length difference. Correct? It is along the same line, same horizontal line, right from the source to C to O. Right, along the same horizontal line. So definitely there is no path length difference. X is 0. Corresponding to that, phi is 0. And we are getting central bright fringe. Now, the next one, where is the bright fringe? Yeah, it will be corresponding to 2 pi. The wave diagram also we had seen 2 pi. After that, again, constructive interference in the above diagram we have seen. So in terms of the path length difference equivalent, how much it should be? 2 pi means lambda, correct? So 2 and 2 on either side is corresponding to path length difference of lambda. Means this 2 lines, the brown one arriving at 2 above O, they are having the path length difference of lambda. And hence, similarly, once the ray is arriving, we can say arriving at 2 below the O, will also have the same result as it is having for the above case. Got it? Now next one, where will be the bright fringe? Next bright fringe, that is your first bright fringe, right? What we got it, number 2, is a first bright fringe. The next one, where it will be? Yes, in terms of the path length difference, it will be on either side. It will keep on going, keep on going. So yes, next where it will be? Tell me. That is your 0 lambda. After that, where it is? 2 lambda, 3 lambda. Correct. All full wave, we are getting the same result, right? Simultaneously, if they are going up, both y1 and y2 will go up. So they are going to make it. So what we got it corresponding to the first one here, if I'm taking right here, this first one, whether phi is 0 or x is 0, I'm getting your first bright, no, that is central bright fringe. Let me correct. This is your central bright fringe. Okay, as we do. So path length, it was there. Just a minute. Length difference. So here, first one where phi is 0 or x is 0, that is your central bright fringe. So we'll write that central bright fringe. Clear up to that? Just a minute. Yeah. Similarly, the second one where phi is 2 pi, right? Second one, you check it. Phi is 2 pi. You are getting after the central bright fringe, this is at O, right? This is at O. Where is my first? After that, first bright fringe will come. So I'll write here first bright fringe. Where it is? In the figure, this is at 2, and so on either side. The next one, where your phi is 2 pi, x is 2 lambda, phi is 4 pi, phi is 4 pi, and this x is 2 lambda. I'm going to have my second bright fringe, and so on. Got it? So alternate, we can get alternate. Many will come. They are very close to each other. For our convenience, we are showing this much so that we can understand. But they come in mm. So if I'm taking say 10 centimeter of the screen, so many things will come in that. Right? Just an idea. So this way, the next set it will be giving you third bright fringe. Similarly, we can have fourth bright fringe. So position of this central bright fringe, of course, center of the screen, first bright fringe on either side, that position we can find from your central bright fringe. I can take this, say this is my central bright fringe, and if I'm taking this one, I'll say this as normally we give it by y. So we'll be taking this y1 for the first bright fringe. Got it? At 2, we are getting first bright fringe from the center only. Similarly, if I am taking the number 1, this is your first, that this is your first dark fringe, and we represent it by y1 from here to here. It will be by y1 dashed, right? For the dark one, y1 dashed. These are the position of first bright fringe and the first dark fringe. Got it? Similarly, we can have second bright fringe represented by y2. It will come above. Both the side of the screen. And for the second, the second dark fringe, we'll get y2 dashed. We can calculate this y1 dashed, or y2 dashed, or in general yn and yn dashed. Very easy to calculate. That we'll see next. First, you note it down.